So,
okay, hello.
Let's get started.
Alexei, nice to meet you. And we have a class with Chinese students who are going to be math teachers. So please tell about your product. I already told that we have some startups and companies who are doing math teaching in Russia as well in other countries. I mean, startups from, we consider some startups and products from other companies. And these students trying to tell us about the Chinese products doing the math teaching. So it will be interesting to connect with you and to know what is new and what is new in math teaching from your side. Please.
Thank you very much. First of all, let me acknowledge my admiration for future math teachers, because it's really good profession. It's really important for our civilization. And it's a pleasure to me to explain how we do this thing in Russia, how we do this in Moscow. My name is Alexei Zaytsev. I got my PhD in algebraic geometry in Amsterdam. Then I got a postdoc position in Dublin, in Quebec, Russia in 2012. And we started our company in 2013, before all these COVIDs and other things, because we understood at that time that it's time to create new approach for teaching math and other subjects. And you know that our strategy is actually based to not replacing a teacher. It's a different story. First of all, the big thing is to do with average students, because we know talented students. Actually, I'm a member of Olympic jury in Russia of National Olympiad, and we saw that a lot of talented people actually they're already actually covered by other teachers, but most students, average students, they're not covered, and it's a problem. And our main goal to create personal education track for every students. The digital math teachers cannot be replaced, but it can be supported by our system. Look, this is phone. This is phone was looked less than 100 years ago. This is current phone. It's Huawei, by the way. We see that's actually horses 100 years ago. That's car now. And look at, this is textbook 300 years ago. And this is textbooks now. I can't see much difference. And it's a point to make a next step in evolution of textbooks. Not replacing teachers, but try to replace textbooks. And actually, this is basic approach for companies. They are doing maths, and they're doing actually services for teachers, not for university. For university, we saw different approach by other companies. And you see on these slides, main company, Newton Alta, iSquirrel, it is Chinese company, which is basically tried to repeat technology of Newton. Alexa, they now doing different technology. They did item response theory. Now we actually try to imply different technology. Duolingo, Dreambox, and I skip a couple of slides. The most popular company right now is Brilliant. They also use different approach, not like we did. And there are two basic approach for adaptive learning systems. Item response theory, and you saw how they did it in Alexa, for instance. And this is things how to find the good tests questions for students. And based on this question, how find next good questions. The problem here that we initially assume that knowledge grows like logistic model, which is actually maybe not true at all. Let me skip Newton. The next approach is using, it's called bias tracing model. They used hidden Markov model. And this is model based on, of course, hidden Markov process. And the main thing here is that we should a priori know this probability distribution, which is actually a lot. They're really a lot. Basically, you knew everything about your students. We try to create our system basis of our system is basically on two parameters: knowledge parameters and probability parameters. We have two main projects. It's 01 Math for general audience and digital teachers in Moscow. The digital teachers is widely used in middle school in Moscow. Almost every school uses this project for daily teaching math. For last year, from 2nd of September, we had 7 million visitors. It's basically almost 7,000 users daily. It's 8,000 teachers. In Moscow, we have 6,000 teachers of math teachers, but also physicists, informatics teachers. They also used our project as well. Achievement. Our project 2 times was nominated for UNESCO Prize, Artificial Intelligence in Education, and in 2019, in 2020. We created project for Moscow Digital Teacher. It's, like already mentioned, it's widely used in Moscow schools. Last month, we won Digital Summit, also got VTB Grand Prix in Industrial Data Fusion 2025, and yesterday we also won Smart City Conference. It's surprising ourselves, but I should say this thing anyway. Now I'm going to explain our project, our system, and split it to 5 parts. First part is students. It's really important how you read inputs of your students, how you follow of behavior of your students. The second part is content. And it's impossible to take ordinary textbook and create a system on base of ordinary textbooks. As you create this thing, it should be 10 times more exercises, probably 15 or 20 times more details, and everything should be connected. This is a third part, graph of concepts. You need to create graph of concepts. How do this concept to connect it to each other? The fourth part is personalization, how you personalize this graph for each student. And the fifth part is teacher. The teachers use your system heavily. They basically, students got all this knowledge through teachers. Therefore, the services for teachers should be really easy to imply for classes, really easy to imply for homework. And you need to present for your teachers all details in smart form, how students did homework, what is problem of each student, and what is common problem, and etc. First of all, about content. The quality of your platform depends almost linear on your content. If you did a bad content, don't expect that you have a good platform. And this is work should be done almost on daily basis. Every day you need to improve your content, find new connection, give details, hints, etc. Many things should be done. Secondly, you need to read your students. Almost everything that might be written by hand in paper should be possible to input in your system. Of course, as soon as you have a rich variety of inputs, you need to recognize everything well. And of course, you should have some limitation because it could be just identical expression. So x equals x is fine. You need some limitation as well. Handwriting. This actually looks nice and attractive, but to be honest, in practice, it's not really useful. But looks very nice and attractive. We have a system of handwriting. You write everything by hand. It's recognized in LaTeX form and then put in our computer science system, computer algebra system. That is fine. The second, I still keep explaining how we interact with our students. And important things, it's a problem which it's a layers problem. And if you do something in one layer, it's recomputed everything in other layers. So in this form, you can create a really complicated problem. You split this into layers and you understand each step of your students. And you can help students for special layer, for instance. I explain it in a few slides in more details. It's special inputs for inequality units. It looks like everything already done by computer systems. You can input everything, but actually not. There are a lot of things, which is small things, big things, which is never actually created by programmer. You need to create these things, and you need to create in efficient form. Here's an example how we input inequality in our system. You need to have interactive problems. Whatever you do on slide, whatever you do in problem, immediately should show up on your platform. For instance, here students input computation and immediately see its computation on graph. Can move it, can see what's going on there. No, it's here. It's keep going. If it's three-dimensional things, you need interactive model. It can be rotate, zoom in, zoom out, and it's immediately in statement of problem. We do it in such way that students can help himself to understand problem more efficient. And of course, it's happened in solution as well. Now I go in adaptive learning, how we actually create our adaptive learning. It's structured by actually three main steps. First of all, you work with fixed problem. You try to help students in fixed problem. Secondly, you work within a concept. You try to explain to a student this concept from different forms, for different approach. And secondly, and third, you work with concept itself. I have already almost have a limitation in time, therefore I'm going to skip a couple of slides. If you work with a single problem, you need several attempts, point errors, general hint, soft hint, penalty hint, personalized hint, an interactive problem, shifts problem. For instance, just simple things. If there is a mistake, show up, where is it? If somebody makes a mistake, give him a hint, general hint. It can be not just a text, it can be a problem as well, which leads to solution of this problem. It's personalized help. We actually understood how create a personalized hint to guess what's going on with head of students and give them really nice help to solve this problem. Let me skip this thing. How to construct graph of concept. It's really a difficult story and nobody actually knows it. And we try to solve this problem for our system. First of all, we use NLP. We try to understand which problems close to solutions. And we use BERTA's pre-trained BERTA system, and we training on our problems. We try to find connection between these things. And then we ask experts to clean up these connections and put more connections as well. Then Bayesian statistic, of course, and other things, we use it to create graphs. This is actually a table which is connection between this cosine distance between our subtopics. And this is a real graph for our system. Now it's have more nodes and more vertices, but it's a real graph for our system. You see how our concept to connect each other. And this graph used for personalized track for each student, because we compute knowledge score in each point, and then we decide what should be next step for students based on this knowledge score and behavior of other students. Let me explain how we do this choice. For instance, we have a nodes n which connected to nodes x and y. Then we're able to construct the zone of knowledges. X is axis x, y is axis vertices, vertical vertices axis. And you see the points, red point is a position of students. And you see the zone, the probability zone. In this zone, students can solve this problem with probability 0.956. And now we have to decide how we should move our students. And you see this is sort of global maximum for our students. We have to move the students to this boundary. And this is probably the shortest way to move them. But this is global. This sort of, we don't take into account behavior of student itself, like everyone should be moved to this zone. But now we have to take into account the students itself and behavior of other students in a similar situation. We create new vector, a vector of behavior of other students in this similar situation. And this vector helps us to find personalized global maximum for these students, and then we move the students to this personalized maximum. It looks like that. We find the problems. Green zone is a good zone, yellow zone is average zone, red zone is a bad zone. Then we're creating sort of personalized path. Then we actually estimate other students in the similar situation, and then we recreate sort of order of maximum order of subtopics in this sense. This is new approach. We try to actually find new approach to correct our graph of concepts. Here is a Tecker decomposition. It's a standard SVD decomposition. And here we actually, based on this decomposition and behavior of students, we find the packages, which is probably new vertices for our graph. And then we estimate students in these vertices. Let's go. Let me probably final step in my presentation. It's efficiency. We can talk a lot about system, complicated algorithm, and etc. But main thing, how it works in practice. What we did, we take a national exam. We take students, it has a lot of students there, with about 8,000 students. We tested before, and where we saw what's happened to the students in national exam. And you see that students would work with our system dramatically improve their results on national exams. It's like 18% more than students which never work with our systems. And it's happened for 2 months, between 2 and 3 months. And basically it was average student. We took
Alexei, thanks a lot.
It's the last slide.
To finish.
Yeah, it was the last one actually, and you see this real result of this real children, which is actually improved their knowledge,
fine.
And actually was the last slide for our presentation.
Okay, thanks a lot. I want to ask you one question, please. Some of the pages are in Russian. Are you going to go abroad? I mean, to give your product to other countries? Maybe in future, China as well?
Actually, we translated our system in Kazakhstan, for instance, and what you see now in GPT, for instance, GPT is a nice things to ask questions and nice things to translate. We say this large language model actually nice things to use it, like ask question if you know these things and ask question to translate something, right? And nowadays, actually, not really big problem to translate your problems, your solutions using GPT chat. It's not so good, well done like a math teacher did it, but you can use GPT to translate it. But directly We don't have a translation right now in English.
Okay, great. Maybe if there are some questions, dear students, do you want to ask some? Anyway, Alexei, there is some, how to say, преграды для быстрого такого восприятия, наверное.
Yeah.
Anyway, thanks a lot for the introduction, and I think you have a good example for math teaching, and I think it will be useful to our students to know about your company, about your product. Thanks a lot. Now we are finishing, and this is the end of our lecture as well. Thanks a lot. Bye for now.
Bye-bye.